Then coming to one more important concept, that is the strength duration curve. Strength duration curve for various tissues have been plotted, and they will study which tissue is easily excitable, which tissue is less excitable. So here they have plotted the graph. Always see the x-axis and y-axis. Here on the x-axis it is given duration. Duration means it is the time period. Then comes the strength. Here we are calculating how much strength is required to create an action potential. And they have plotted the graph like this and finally found out the excitability of the tissue, like how far the tissue is excitable. And here we have to understand about three important terms. It is all of them are very important for MCQs also. So here we can see that this is the starting point where the action potential was created with a minimal impulse. Here you can see that this is below it there is no generation of action potential. Below this region there is no generation of action potential. So this is the region where the action potential is created with minimal impulse. So this minimal impulse, as you can see here, we have marked it here. So this minimal impulse that is required to generate an action potential is called as the Rheobase. Rheobase is the strength of the current, is the minimum strength of the current to create an action potential. And here we can see that with this minimum strength, it took me this much duration because I'm giving very minimal strength, very little strength. So it will usually take a longer time to produce an action potential in a particular tissue. So this duration with Rheobase current, see here, I have marked it again down here also. This duration with the Rheobase is called as utilization time. This B is nothing but called as utilization time. How much time is utilized to produce an action potential with a minimum current? Utilization time, we have to use a Rheobase current. Rheobase current. And I have marked one more C here, C option, which is what we have done is we have doubled the Rheobase. For example, the Rheobase is 5 millivolt. We will double the Rheobase 10 millivolt and see in how much duration the action potential is produced. So this duration is called as Chronaxie. Chronaxie is also along the y-axis. Most of the time people get confused whether Chronaxie is the duration or the strength of voltage. Chronaxie is not the strength of voltage. Chronaxie is the duration when the strength of voltage is twice the Rheobase. If I increase the Rheobase to twice and see in how much time period it is giving an action potential, that is called as Chronaxie. Chronaxie is the time period. And they say that Chronaxie is a better measure for measuring the excitability of the tissue. Why? Because if I use a Rheobase current, I have to wait for a very long duration, like a utilization time. As you can see here, we have to wait for a very long duration to get an action potential, which we don't want. We want to happen things very fast, like we want to study various tissues, multiple tissues faster. So we twice the Rheobase current. What is the Chronaxie for that particular tissue? And suppose if any tissue is giving an impulse like this, for example, let's take this is another tissue like A. Now tell me which tissue is easily excitable, of A or B. For A, if I use twice the Rheobase, what is the Chronaxie duration? See here, the Chronaxie duration is this much, starting from here to here. The Chronaxie duration is this much, or in the y-axis it is much longer than that of a side B. So which tissue is more excitable in our example? The tissue B is more excitable. Here B is more excitable or easily excitable than A. So all of this will be given an option. They will give the option like A is excitable more than B, B is more than excitable more than A, and they will be confusing with all the option. A is equally excitable to B. Then they will tell Chronaxie is the strength used. Chronaxie is not the strength, Chronaxie is the time duration. So we have two time duration, which is the Chronaxie and the utilization time. Let's revise the definitions one more time. The Rheobase, it is the minimum strength required to produce an action potential. Here we are not bothered about how far that duration is happening. Then utilization time, it is the time required to produce an action potential with Rheobase current, that is the minimum current. And Chronaxie, it is the time taken to produce an action potential when twice the Rheobase is given. When we give twice the Rheobase, what is the time period that is creating an action potential? So Chronaxie is the best measure for the studying the excitability of the tissue. And excitability of the tissue, like the Chronaxie time is for a nerve fiber is less than skeletal muscle, and for a skeletal muscle it is less than cardiac muscle, and for a cardiac muscle, it is less than the smooth muscle. So which tissue is easily excitable? If the Chronaxie time is small, is it good or bad? It is good. It means that it is easily excitable. It is getting excited in a much shorter duration. So the nerve fiber is the one which is most excitable. We have to remember this order also. Nerve fiber is the most excitable, followed by skeletal, cardiac and smooth. While studying also, we will be studying in the same sequence, so nothing to mug it up. You can just remember it, nerve fiber followed by all three groups of muscles. Then coming to the sensitivity of nerve fibers. The sensitivity of nerve fibers, there are various group of nerve fibers like A fibers, B fibers and C fibers. This A and B, they are myelinated fibers, and whereas the C fibers are non-myelinated fibers. And in this, what we have to remember is what is the sensitivity of this specific group of fibers for a specific impulse. Suppose if we give a pressure stimulus, which fiber is more sensitive? A fiber is the most sensitive for pressure, followed by B, followed by C. This has been constantly asked in MCQs also. They will give a classical example of a student sleeping in class. That is the example. So this is the example. You don't have to worry or think much. Students sleeping in the exam, and they in the class or something, they will give their history and which fibers are most sensitive. That is the question they will ask. And obviously all of us know it is the A fibers. In A fibers, there are various divisions: A, alpha, beta, gamma and delta fibers. In the pressure sensitivity, the A delta will be the most preferred choice of answer. A delta fibers are the most sensitive to pressure. So ABC, it's easy to remember ABC. Coming to local anesthesia. Local anesthesia also ABC. You don't have to mug it up. For pressure and local anesthesia, we don't have to mug it up. It is the general normal sequence. And in this also, which fibers are more sensitive? A alpha and A beta. They come like A alpha, A beta, then followed by A delta and A gamma fibers. So this is the sequence. So for both pressure and local anesthesia, we are going to go for ABC. There is a controversy with local anesthesia. Local anesthesia, some of the physiology and medicine books, they have given a different sequence. But I would still suggest you to go with A fibers only. Why? Because there is a book called Miller's Anesthesia, which is referring that very clearly that it is the A fibers which is more sensitive to that of the local anesthesia. If an anesthesia book is saying that the anesthetic agent is more sensitive to A, then our most preferred choice should be A. Even though the physiology and the medicine books differ from it, still the best option is, and the key is also nowadays made for A only. Then coming to the last one, that is hypoxia. Hypoxia is one thing that we have to remember. The sequence is BAC, back. Just remember back for hypoxia. Hypoxia is back. Just remember that you are going on a trip and hypoxia is back. BAC. So this BAC is the only one difference for hypoxia. Rest everything is ABC. Just remember it.